Okay, we're in section 5.4. I know it's word problems. I know students have difficulty with word problems. Again, I'm going to encourage this. Read it, try to understand what you've read, write down what they're looking for. All right, you really should. There's a variable here they're looking for in the problem, and then try to write down what they're saying about it. Every single problem is going to do the same thing. I'm going to try to visualize some of them with a very simple stick picture, though. All right, so let me switch over. And again, we'll do all 7 problems. We have examples to do. We'll do all 7 examples. Again, for students that find it very difficult to follow, they say it goes too quickly, they can't copy, whatever. People have different skill sets. So what you may want to do is watch these little embedded videos in addition to watching the lectures. All right. The lectures will be posted later in the week, and you're more than welcome to watch those lectures if it's helpful. All right. I would say pay attention though. All right. We'll go up to problem number 7. Then there'll be problems that you try on your own. And here's the weak link. If you're not trying, nothing's going to sink in. All right. You got to try. All right. Not just simply say, oh, gee, it's too difficult. I can't do this. You got to try to do it. All right. We'll do all 7 problems now. All right. Let me do another share with you. And give me a second. Okay. We're on problem number 1. And what does it say? It says, you have a collection of coins. All right. There's 17 coins altogether. And the value of those 17 coins is $3.35. Pretty easy to understand, by the way. 17 coins, $3.35. We're talking US money. It's a collection of dimes and quarters. So I'll put this over here. So D, now some people say, oh, D's dimes. No, D is the number of dimes. So there could be 1 dime, 2 dimes, 3 dimes, 4 dimes, yada, yada, yada. And what else is there? There's quarters. So I'm going to say Q isn't quarters. It's the number of quarters. All right. So D represents the number of dimes and Q represents the number of quarters. Now, what do I know? Just in the first sentence, I know that if I added the number of dimes and the number of quarters together, I would have 17 coins altogether. And what else do I know? I know there's $3.35. Well, let me write this down. So that means every dime I have is worth 10 cents. So it's going to be 0.10 D. For example, if D was 1, it'd have 10 cents. If D is 2, it'd have 20 cents, yada, yada, yada. And every quarter is worth 25 cents. So if 1 quarter, I have 25 cents, 2 quarters, 50 cents, so on and so on. How much money would I have? $3.35. Okay. Now, I want to claim that I'm not opposed to this right now, 2 letters, but at this level of the game, we only want to use 1 letter. So what I want to do is I want to take that D plus Q, right, and solve it for Q. Actually, I want to solve it for, let's see, they want to know the number of quarters in it. So I'm going to solve for the number of dimes, all right? It doesn't matter, though. If I know dimes, I know quarters. The number of dimes, I know the number of quarters. So I'm going to write down D is, again, what I'm looking at, look at this over here, would be equal to 17 minus Q. So what I'm going to do here is I'm going to take this D, which is 17 minus Q, and plug it in here. All right, let's write that down now. 0.10 times D. What's D? 17 minus Q. All right, plus 0.25 Q is equal to $3.35. Let's keep moving through it. And again, I know it's difficult. If you have trouble with arithmetic, please use the calculator. But I don't think the arithmetic's that bad. I make mistakes though. So what do I get? I get 1.7 minus 0.1 Q, all right, plus 0.25 Q equals $3. I'll just say 3.35. I'm not thinking about money anymore. So I'm going to simplify the size, 1.7. And let's see, 0.25 minus 0.1 is going to be plus 0.15 Q. That looks like a G. Let me get backwards on that. 3.35. I'm going to subtract 1.7 from both sides. And what do I get? I get 0.15 Q equals, let's see what you get over there. Let's see, $1.60. I'm sorry, I keep saying money, money in my brain. 1.65. All right. Now what do? I divide both sides by 0. It's the coefficient on Q, by the way. 0.15. And I realize that's really tough. It's not tough. You can do it. So what does Q represent? Let's see. If I looked at that, I'd say it goes in 11 times. All right. So what does that mean? It means I have 11 quarters. Let me go back up here and make sure you know what I'm talking about. There's 11 quarters. How many times would there be? 6 times. All right, let's talk about the value of this. We'll answer the question later. This would be 60 cents, right? Let's see, that would be 275, right? Let's add that together. I don't think it's that bad to add together, right? You get $3.35. What was her question? How many quarters are there? I got it right here. There's 11. And look at the key. It says 11 over there. All right, let's go to number 2. And number 2 is right here. And again, a lot of times when we read the tough time understanding what they've read, that's a problem. You want to try to understand what you've read. So it says a passenger train leaves a depot 1.5 hours after a freight train leaves the same depot. Well, I'm going to put my depot down. It's like a train station, right? And they're talking about 2 trains now. One is a passenger train and one is a freight train. Okay. So a passenger train leaves a depot 1.5 hours after a freight train leaves. I'm going to say this probably is going to be a distance equals a rate times time problem. All right. You know, trains are traveling and there's time. I can see that. So it says the passenger train is traveling 18 miles per hour faster. So I'm going to kind of summarize this information for you. So I'm going to put down passenger train, and it's really the first guy they talk about. I'll say R1, T1, right? And D1. I'm going to say freight trains are the second guy they talk about, R2, T2, D2. And again, I'm just reading it. So I'm reading. Some things may confuse you. Some things may be more clear. Where they say the passenger train is traveling 18 miles per hour faster freight train. Well, you know what? That's a rate problem. So I'm going to say that the freight train is going X miles per hour. The passenger train would have to be going 18 miles per hour faster, which would mean what? X plus 18. All right, let me repeat this over here. It said the passenger train is going 18 miles per hour faster. That's a rate than the freight train. That's covered. All right. If it takes you time to read something you read, please take your time so you can understand it. Don't let someone rush you into understanding. You take your time to understand what you've read. All right. Find the rate of each train. If the passenger train overtakes the freight train, now here comes the real story here. So I want to claim to you what's happening over here. The freight train leaves first. Okay, freight train leaves first. Let me put this down for you. So he leaves and he's traveling, right? He's going slower than a passenger train now. And what happens to the passenger train? Passenger train leaves, but he leaves later, right? And he's going much faster, 18 miles per hour faster. He's eventually going to catch up to him. All right. He's eventually going to catch up to him. All right. So let's take a look at it. So it says, find the rate of each train. Let me box what they want. They want this guy's rate and they want this guy's rate. I don't know it. Find the rate of each train if the passenger train overtakes the freight train in 2.5 hours. So what does that mean? The time is 2.5. All right. There comes a problem with students that they don't remember the beginning of the story. The passenger train waited around for 1.5 hours. What does that mean? The other guy has been on the track now for 2.5 plus 1.5. Let me write that down for you. 2.5 plus the head start he was given, 1.5. And what would that give me? 4. All right. I'm going to put distance down. And what's distance? Rate times time. So what do you get up here? 2.5 times x plus 18. What's the other guy's distance? 4 times x. Again, we're using rate times time. What do I know? And again, I'm going to emphasize it to you. The only thing I know of equality in this problem over here is that the distance to pass a train goes is identical to this guy over here. So the distances must be equal. And let me write that down for you. So 2.5x, I'm sorry, 2.5 times x plus 18. Like what I'm saying over here, this guy's distance has to be the same as that guy's distance. And let's write that down for you. All right, I got my equation. I'm going to solve it. So what do you get? 2.5x plus, well, 2.5 times 18, 2 times 18 is 36, and half of 18 is 9. That'll be 45. Again, if you're struggling with arithmetic, I want to encourage you to try to get better at it. But again, if you really struggle, I guess you have to use a calculator to do that. All right, let's keep going. I'm going to subtract 2.5 from both sides. I'm no longer thinking about the word problem. I'm thinking about solving an equation. What do you give here? 45 equals, what would that give you? That gives you 1.5, right? What am I going to do now? Divide both sides by 1.5. And again, I make mistakes. I know that, but I think I can figure this one out. 1.5 divided by 1.5 is 1, and 45 divided by 1.5 would be, let's see, that would be 30. I'll put this over here. All right. So someone says, oh, gee, I'm done with the problem. You're not done with the problem, by the way, because you don't even know what this means at this point. You got to go back to their question. And what was their question? Their question was, what's the rate of each train? Now I can write it down. So if I know x is 30, the rate of this train over here is 30 miles per hour. And the rate of this train over here is 30 plus 18, which is 48 miles per hour. That's what they wanted to know. Let's look at the K. And it says passenger train's going 48 miles per hour and the freight train's going 30. Relatively simple question. What's the problem though for a lot of students? It's understanding what they've read and how it relates to algebra. Let's go to the next page and we'll start number 3 now. All right, let's go to number 3. And let me just see if I got to push things over a little bit. Whoops. Sorry about that. Let me push this out of the way. And I'm going to start with number 3 now. All right. So, the way I do things and the way you do things may look different, but it's really the same story. And what I'm going to do is, typically mixtures at this level of the game, there's going to be 2 things combined together. I'll draw a little picture of it. Whoops, I'll go back to black. And I'll tell you what we're mixing together. And again, it's a quick read. I realize that. You take your time when you're reading, though. Again, don't let people rush you. Including me, by the way. You may say, oh, you go too fast. Well, not really. What you can do is you can wait till the end of the week to watch this video. Go as slow as you like. You can pause the video, play the video, rewind the video, whatever. I also want to claim you can watch these little videos on the side at any time you want. You don't have to wait till the end of the week. You can anytime you want. All right. So as a coffee merchant combines coffee that costs $5.50 per pound. Let me write this over here. I see a box over here with coffee in it that says $5.50 a pound. That's my abbreviation for pounds. With coffee that costs $4 a pound. There's a label in this one that says $4 a pound. That's per pound, I'm sorry. It's labeled $4 per pound. The other one's labeled $5.50 per pound, right? It says that. You mix them together. You add them together. And it says, how many pounds of each should be used to make? Well, I don't know. So I'm going to say use X pounds here and Y pounds over here. I have no idea what he used. He says, how many pounds of each should be used to make 30 pounds? Now I know he made 30 pounds. That's his mixture. I'm just summarizing in a picture. It's a story that costs $4.70 per pound. All right, I'm going to write things down about this now. I'll push this up and I'm looking at my picture. And what do I know about my picture? I know there's X and Y. So X pounds of the first guy plus Y pounds of the second guy is going to be 30 pounds. I know that much. What else do I know? I know a money problem over here. So if there's X pounds that worth 5.50 a pound, it's 5.5X. That's how much money I have from the first box. The second box, well, it's 4Y, right? I'm talking about the money now. First, I talk about the pounds, then I talk about the money. So the first box, I used X pounds. Each pound was $5.50. The second box, I use Y pounds, and every pound is worth $4. What did I end up with in the end? 30 pounds at $4.70 per pound. All right. So someone says, what are you going to do now? At least I read it and I have some comprehension of what I've read. What I'm going to do now is I'm going to get one letter in the problem by taking the first equation and I'm going to solve it for Y. And what would you get? Y is equal to 30 minus X. And I want to put on what I'm going to do now. I'm going to take this thing here, which is Y, and plug it in here. And I'm going to get something pretty simple when I do that. And let me go through that with you. You're going to get 5.5X plus 4. What do I believe Y is? Well, Y is Y, but it's also 30 minus X equals 30 times 4.7. All right. Again, that if you really tough time with arithmetic, I would say do your best to try to get better at it. But if you're really that weak at it, I guess you'd have to use a calculator. But anyway, I don't want to use a calculator unless I have to. So I'll put this down for you. It's 5.5X. Now 4 times 30 is 120, right? Minus 4X. Let's see, it's a little more difficult, isn't it? And so I'm going to simply say, looking at, I'll write it aside for you. And I can write this over here, 4.7, right? Now, the way you're taught to do this in grade school, I wouldn't do it that way, but most students do. 3 times 7 is 21. Let's see, 3 times 4 is 12, 14, right? And that would turn out to be 141. All right. Now, if I were doing that, it's going to sound crazy to you. I wouldn't have done that. I would have simply said, 10 times 4.7 is 47. And 3 times 47 is 120 and 21, which is 141. I wouldn't have written down the work. All right. But again, don't feel like you have to do it in any particular way, but you should agree upon arithmetic. Let's keep going. And I'm sorry, I made a mistake on the left side. That's 4X. My mistake. I just noticed it. So what do you get over there? You get 1.1X plus 120 equals 141. What's nice about these problem sets, you have an answer key. If I do make a mistake, I'll know I made a mistake. I'm going to take 120 from both sides. You get 1.1X equals 21. Wow, looks like a tough one, doesn't it? So I'm going to divide both sides by 1.1. Right? And what do I get over there? I get X. And let's see, 1.1 into 21, right? Write that down for you. 21, 1.1. Now, what you did in grade school, your teacher told you to do this over here. All right, let's say 1. It's 11. And what do you get there? 1, 0. You know what? I think I made a mistake somewhere. 1 times 11 is 11. Oh, no, that's okay. I think I made a mistake somewhere, though. Yeah, I did. I think I did anyway. Look at my key. Yeah, I made a mistake. So I'm going to look at it again. I'm going to get my eraser out. And I'm glad I made a mistake. I'll tell you why. If I'm struggling with, the result of the arithmetic, I'm probably saying there's a mistake somewhere. So let me just erase this over here. Erase this over here. And I want to look, see if I copy the numbers right. I know it's tough. I don't want to do that. I just want to keep going. Well, I want to see if I did it right. 5.5, 4, 470, 30 pounds. Yeah, I see that. And let's see, x plus y is 30. I see that. 5.5x, 4y, 30 times 4.7. 30 times 4.7. I wrote the equation down for you. So 5.5x and 4 times 30. I'm just looking over my work. So I'm doing. And it's important you do that too. Don't give up though. As a lot of students will say, oh, I can't do it. I can't do it. You want to do it. You want to try. Don't give up. Right? Resilience is a characteristic of success. So let's see. 5.5x, 4 times 30 is 120, minus 4x. And 30, I said 47. 3 times 120 and 21, 141. And, oh, I see it now. It's not 1.1, is it? No, that's crazy. My eraser out now. There's something wrong over here. 5.5 minus 4 is 1.5. All right. Minus 120. Back in the ball game now. There might be another mistake, though. What do you get? And don't be discouraged by mistakes, by the way. What does that give you? 21. What I'm going to do now, divide by 1.5. And what do you get there? X equals. Let's take a look at that. Not look that bad. I'll do the arithmetic again, though, for you. So I'm going to say 1.5. I'm going to push over the 1 now, okay, into 210. That would go in once, 15. Let's see, you get 6, 0. And 15 goes into 64 times, right? So what's x 14? Okay, let's take a look at it. And again, I'm not saying it's the right answer, by the way, but I want to go back over here and I want to see if I can make sense out of it. There's 14 pounds of this. All right, we'll look at our key later. And what would the y be? The y would have to be 16 pounds. Now, why is that? It has to add up to 30 pounds. Let's look at the answer key, though. Let's see how we did. So it says 14 pounds of the 550. I see that. And 16 pounds of the $4 coffee. We're doing okay. All right, so that was number 3. Let's go to number 4. Yep, I know it's tough. We want to give it a best shot possible. All right. Another mixture problem. And again, it's a quick read. I realize that. And again, it's so typical. We're going to take 2 things, but it's not typical in the real world, though. Mixtures are not just 2 things. So a hospital staff mixed a 75% disinfectant solution. I'm going to put a label over this. This is 75% disinfectant. And they mixed it with a 25% disinfectant solution. All right. So how many liters of each? I don't know. X liters, Y liters. This should be reminiscent of the last problem. How many liters of each should be mixed to make 30 liters of a 40%? Well, I think I can write things down now. What can I write down? X plus Y is equal to 30. Let me circle what I just said over here. That should make sense. The next thing is going to be, well, how much disinfectant I have? Well, of the X liters, 75% is disinfectant. So I'll write that over here for you. 0.75X plus 0.25Y, right? I'm doing a disinfectant now, is going to be 40%, which is 0.40 of 30. All right. So I'm going to push this up. I'm no longer thinking about the words. I'm thinking about the problem. And this is too many letters for me. So I'm going to take this thing over here, just like I did prior, and solve for y. And what would I get over there? 30 minus x. I'm going to tell you this over here. We got 30 minus x, which is y. I'm going to plug it in here and see what we get. So what do you get? 0.75x plus 0.25y. What's y? 30 minus x equals 0.40 times 30. All right. 0.75x plus, well, let's see, what would you get there? And, you know, it might be tough. Let's see, I guess 3 times, well, it'll be 2.5 times 3, 250, 750, right? 7.5. All right. So again, so what you do over there, I did 30 times 0.25. Quarter of 30 is 7.5, by the way, minus 0.25x. And let's see, would this give me 12, right? All right, let's keep going. So again, if you have trouble with arithmetic, I'd say practice, practice, practice. I'm not very fast at arithmetic, but I can do it. And I do make mistakes sometimes. So 0.75 minus 0.25 is 0.5x plus 7.5 equals 12. And we have an edge key to look at too. Don't worry about that. So I'm going to take away 7.5 from both sides. And what do you get? 0.5x. Let's see, you get 2.5, 3.5, 4.5. And I'm going to divide both sides by 0.5. And what do you get? X equals, well, that goes in 9 times, doesn't it? So I think I know what X is, but I can't remember the story. I go back. I can always reread it, but I think X is 9. Now 9 what? Well, I got it written down over here. It's 9 liters. So I'm going to say this is 9 liters of the 75%. We'll look at the key later. The other guy would have to be 21 liters. Let's look at it. See if we got it right. 9 liters of the 75%. I see that. 21 liters of the 25%. I see that. We got it right. Good. Next one, which should be number 5. And number 5 is a running problem. And I'm going to say this is most likely has something to do with distance equals rate times time. Okay. So a long distance runner starts on a course running at an average speed of 6 miles per hour. 1/2 hour later, a second runner began the same course at an average speed of 7 miles per hour. So I'm going to say this sounds like the train problem we did before. So I'm going to say runner number 1, right? We'll write this guy down. Runner number 1. We have distance 1, rate 1, time 1. And we also have a runner number 2. So he's going to do a distance. This is distance 2, R2, and T2. All right, let's write down the details now. So a long distance runner started on a course running at an average speed of 6 miles per hour. So write this over. That's a rate, 6. It's 6 miles per hour. Now, I might not understand this part of here, but it says 1/2 hour later, a second runner began the same course at an average speed of 7 miles per hour. Okay. How long after the second runner? This is the second runner. This is the first guy. How long after the second runner started? I don't know. He's running for X hours. Will he overtake the first runner? Now, I want to point out what this means. It's like the old story. This guy takes off. This guy gives him a head start. He's running faster. He's eventually going to catch up to him. When he does that, he'll overtake him. Here's the problem students have. They don't know the head start part. Read it. What does it say? The first guy's given a 1/2 hour head start. What does that mean? He's been running for X plus 1/2 of an hour. What's distance? It's rate times time. It's going to be 6 times X plus 1/2, which is 6. I'm sorry, I made a mistake there. 6X plus 3. And this guy's going to be 7X. What do I know? I know their distances are equal. So this guy's distance here and this guy's distance here are the same. Why is that? He overtook him. So I'm going to say this distance here must equal that distance there. And let's write that down. So what do you get? 6X. Whoops, sorry about that. 6X plus 3. That's the first runner's distance. Has got to be identical to the second runner's distance, which is 7X. How do I solve that equation? Take 6X from both sides. Again, I'm no longer thinking about the problem. I'm thinking about solving an equation. Don't box that though. I don't think that was a question. What does it say X is? X is 3. So, what was the question though? How long after the second runner started? It's this question over here. And what is that? The answer now is going to be 3 hours. Let's look at our key, see if that's true. 3 hours. 3 hours. Let's go to problem number 6. A mixture problem. Put this down. And let's write down. A butcher has hamburger meat, 21% fat. Write this over here. Seems like he's interested in the fat. He has some that's 15% fat. How many pounds of each should be used? I don't know. X pounds here. Y pounds here. How many pounds of each should be used to make hamburger that's 17% fat? And he wants to make 90 pounds of it. Well, it's deja vu all over again. Let's write this down. X plus Y equals 90. Where's that coming from? Here. Now let's write down how much fat the guy's got. He's got a lot of fat. 0.21x plus 0.15y. What am I saying? 21% of the X stuff is fat and 15% of the Y stuff is fat. How much fat you end up in the end? Well, 17% of the 90 pounds. All right, let's go through the work. All right, what's the work going to be? Well, we've been doing this over and over again, and hopefully it really patterned to it. Solve for y. Y equals 90 minus x. Then I take this thing here, and I plug it in for y right over here. Let's write that down for you. I'll push this up. So 0.21x plus 0.15y. Well, you can use y if you want, but I'm going to put down 90 minus x equals 0.17 times 90. All right. And again, I realize for some students, they really think it's a killer. Maybe it is, but let me give it a shot. So 0.21x, we do have an answer key. 15% of 90 is, let's see, that would be 9 and 4.5, 13.5. I'm not beyond making a mistake, by the way. Minus 0.15x. Let me do this. This should be 9 and 6.3, 15.3. Again, I'm not beyond making a mistake. I make mistakes all the time. So 9 and 6.3 is 15.3. Let me see if I can do that arithmetic. And 0.21 minus 0.15 is going to be 0.06, right? Plus 13.5, 15.3. I can subtract 13.5 from both sides. It's nasty. I realize that. Let's see, 1.5, 1.8. Wow, I got to do something now, don't I? Divide both sides by 0.06. And you're going to get something. Well, left side's pretty easy, right? So you get 180 divided by 6, 30, right? Okay, let's go back. I don't know what the 30 means. Can't remember. That's why we draw pictures for you. So what does it mean? And we'll look at the key later. I'm going to say looking at it, it means there's 30 pounds here of this stuff. And there'd have to be 60 pounds here, right? Okay, let's see if we got it right. So it says 60 pounds of the 15%. We got that right. And 30 pounds of the 21%. We got that right. All right, last but not least, I think we got number 7. That's on the next page. Look at that. And there you go, number 7. Two planes are 1,425 miles apart, and they're traveling towards each other. Well, I'm going to say this is probably a distance equals rate times time problem. Now, when looking at it, I'm going to say the first thing I know is there's two planes, and they're apart. Well, how far apart? They're 1,425 miles apart. All right. They're traveling towards each other. So I'm going to say, one guy is going like this. The other guy's going like this over here. All right. We'll talk about the details later. So I'm going to say one plane. I'll just call this the first plane. So distance 1, rate 1, and time 1. And I'll call this guy the second guy, D2, R2, T2. Okay, so I know they're 14 and 20, 25 miles apart, but they're traveling towards each other. One plane is traveling 110 miles per hour faster than the other. So I'm going to say this guy here is going X, and this guy's going faster by 110 miles per hour. Right? I'm reading that. One plane is traveling 110 miles per hour faster than the other. The planes meet in 1.5 hours. Okay, 1.5 hours they meet. Now, I hope you realize that if this is a true story, if they meet, they're going to meet closer to the other guy on the right. Right? They meet there. Let's write this down. And we're using this rate times time. So it's going to be 1.5 x plus 110. And this guy's going to be 1.5x. Now I'm going to just, kind of shade in things here for you. And I want to point out, this is the distance. That's that distance there. And this is the distance of this guy over here. What do I know about the addition of those two distances? Would have to equal this thing over here. Let's write that down. So what do I know? I know 1,425 is the first guy's distance. We'll do that later. Plus the second guy's distance. 1,425. Let's see, 1.5 times x is 1.5x. Plus, well, that'll be 110 plus 55. That would be 165 plus 1.5x. And yes, I know some students are struggling with arithmetic and they say it goes too quickly for them. You can always watch little videos on the side or come back later in the week, but you need to think and need to use a calculator if you really have to. All right. So 1,425, 3x plus 165, subtract 165 from both sides. You're going to get 3x. Again, I'm not even thinking about the problem anymore. Now 165 from 1,425. Let's see, that would be 235, 240, 250, 260. 1260. Let me see if that's right. Let's see, 300, 420. Yeah, looks good. Divide both sides by 3. I'll write that down for you. And that would be, let's see, 420, right? Again, I don't even know what x means anymore. I lost track of everything. Well, that's why we put pictures down for you. I know x is 420 though. So what does that mean? Well, if x is 420, this is going to be 420. I'll write that down for you. 420 plus 110. And that would be 530, right? 530 what? Miles per hour. And this would be what? 420 miles per hour. Let's look at the K, see if we got it right. It says 420. I see that, and 530. I see that. All right. So, my claim over here, once you get this done, I'm not saying you're done yet. You got to go back and review that material, but you got to get busy doing things. So what I would recommend you do is, start doing homework. You start to practice, right? You need help, come by during office hours. But after you're all done with this stuff over here, then the web assignment should seem very simple for you. I really do mean that. It should be very, very simple. All right. Thank you for paying attention, and I'll see you guys next time.